Hey folks, it's me again, in the flesh, talking to you about optimization 3.7 in Calc BC here. And the way we do optimization is kind of bringing another meaning to the derivative. We saw that it was a max or min on a graph. Well, here, these are what big businesses use derivatives for, to try and maximize sales or try to minimize the amount of fencing you need for something or maximize volume, things of that nature. When you're an engineer 5 years from now, hopefully you'll be using some type of optimization. The primary equation is what's going to be optimized. The secondary equation is helping the equation get in two variables, okay? And what happens is that there's a big strategy for applied max and min, but I'd like to simplify it and give you the Marashio rules. Okay, the Marashio version is this. This is kind of like, Kennedy, you like this, because this is kind of the steps on which, how you do it, all right? Solve a secondary equation in terms of one variable. Substitute it into the primary equation, all right? So you're gonna have some substitution. Then you give a domain, a reasonable domain, because like if you get a negative number for area, it just doesn't mean anything. Derive it, find your critical numbers, which means set it equal to 0, and then we'll use the second derivative test to make sure it's a max or min. So I think I've talked a lot about it. Let's do an example. Let's do it. Find two numbers whose sum is 20 and product is as large as possible. Hey, I could write an equation for that. Two numbers whose sum is 20. X plus Y equals 20. Nice, nice. So now, oh crap. Now, the product is large as possible. Come over here. I don't like that the camera may not see me. Here it is. Product is large as possible. So that means X times Y has to be some type of max. The Marashio version says one equation, put it in terms of a one variable. There it is. Okay? All these updates, you see what's going on with this computer? All right. Secondly, let's choose a domain. I'm going to say that these numbers, whether X and Y, have to be between 0 and 20. Okay? X and Y have to be between 0 and 20. So if X is 0, Y is 20. If Y is 20, X is 0. Makes sense. The domain. All right. Now, we're going to do a little substitution and some distribution. Here it goes. Ready? Boom. 20 Y minus Y squared equals a max. So I plug this guy into here. Now I'm going to take derivative. I'll take derivative in blue. We get 20 minus 2y. 2y, why is that squared coming out? My mind thinks squares, I don't know why. Equals 0. So see, whatever maximum value that is, when I take the derivative, it's going to be 0. So now you're going to get y equals 10. Well, if y is 10, x has to be 10. Nice, nice, nice. Here, I'll even write, nice, nice. It's within my domain, both of them. So it's looking good. The maximum number that I'm going to have is going to be 100. That's what 10 times 10 is. The last thing I'm going to do is I'm going to check in the second derivative. So if I take another derivative of this, the second derivative, all right, it'll be -2. So that means the number I've got is a max. Remember, when you take the second derivative, if it's a minus, it's a max. If it's plus, it is a min. So this always comes out to -2, so it's a max. Done. Here's all the information I needed. Problem finished. Finito. So it has to be 10 and 10. Do you have any questions? No. Very good. Probably because I can't hear you, but I'm sure I'll hear tomorrow. Let's do another one. Let's do another example. So here's another one. What is the smallest possible perimeter for rectangles whose area is 16 square inches? Well, I guess we can have our base and height between 0 and 16. All right? I don't think it could be equal 0 because then we wouldn't have something. So that's why I'll leave an open circle here. But this is kind of just for the person doing the problem. So I know that if I get an answer that's kind of out of the ordinary, that we have to examine it. So, smallest perimeter. So let me get to my notes so I know what I'm talking about. The area is 16, so base times height equals 16. Fantastic. And then the smallest perimeter. Well, the perimeter is 2 times the quantity base plus height, and we want this to be a min. Hold the phone. I'm going to make the height equal to 16 over, not 20, but b. I don't know where that 20 came from. I don't even have $20 on me. 16 over b. Replace back into this guy. So we get 2 times, so we're going to get 2b plus 32b to the negative 1, I guess. All right? And that's equal to the min. Well, actually, I don't want to do negative 1 because when you take the power rule, something bad's going to happen. Bad. We're going to keep this over b, and this equals some minimum number. Now I have to go to my notes, folks. I don't know why, but I have to go to my notes. No, I'm good. I don't know why. We'll keep it to negative 1. Holy crap. I'm going nuts here, folks. I have Mr. McKeever in the room watching me. He's making me nervous. He doesn't know this. Take derivative. Here we go. If I take derivative here, I get 2. If I take derivative here, I get, I think, negative 32, and then this would be b squared on the bottom, or to the negative 2, and this equals 0. So I'm going to get, all right, I'm going to make this, I'm going to see if I can solve this to equal 0. So I'm going to get 2 equals 32 over b squared. So b equals plus and minus 4. Got that? You can solve it that quick. You're as good as I am. But by the way, ooh, negative 4. Negative 4 is not in our domain. So we're only going to use the plus 4. So I know my base is 4, my height is 4, and the minimum I have is 16. So the minimum is 16. Well, wait a minute. There's one thing I forgot. What was it? Second derivative. Okay, I forgot the second derivative to make sure that that's a minimum. So when I take the second derivative here, I get 32b cubed. 32b cubed. Put in 4, you get something positive. When I plug in 4, I get something positive, which means it's a minimum. Done. Just a real quick test here. I don't usually do the tests, but when I'm on an AP exam, you better believe I'm doing a test. Because sometimes they give you stuff that's not, you never know. They can give you funky. All right, let's do una más for me. Oh, that means 2, but I'm only going to do one more. I'll set you up on the other one, and you'll finish it. All right. On what point comes closest to the point 0, 2? Distance formula. Remember this? Distance equals, and then we're going to go x minus 0 quantity squared, then plus y minus 2 quantity squared. The 0 and 2 come from that point, obviously. Okay? Now, 0, 2, y equals 4 minus x. I don't know why I have 4 minus x squared. I gotta check that. I have to check that. Oh, wait a minute. You know what? I forgot to give you an equation. The equation I wanted to give you up here, it didn't come out. Oh my God, it didn't come out on the printout, but y equals 4 minus x squared. Ah, that's where it comes from. So that would be given in the problem. I apologize. It didn't come up with the math type. So now I would have the distance is equal to, plug this in here. So this, I'm just going to call that x squared because 0 does nothing, plus, I'm going to plug that in for y. So it's going to be 4 minus x squared minus 2 quantity squared. All right, I'm going to combine like terms, yada, 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 FOIL that out. When the smoke clears, I'm going to have x to the 4th, x to the 4th minus 3x squared plus 4. Now, I think you would agree that whether I'm taking the square root or not, this guy, it's the smallest, has to be the smallest. So we're going to drop the square root for now. Yes. Don't let anybody hear this, but we're just dropping the square root. So I just want to know when this guy is the smallest. So I'm going to just say, okay, the derivative of this thing is, I don't know, you tell me, 4x cubed minus 6x, I think. Come back. I'm running out of little room there. 4x cubed minus 6x. All right, so I find out that I get 0, square root of 3 halves, and negative square roots of 3 halves. All right, when I go to solve that and set it equal to 0, you can factor, solve. You should know how to do that by now. So I find out that this comes out to be a max, this comes out to be a min, and this comes out to be a min if I look to put it back in the original equation. So I don't care about the max. I want the smallest numbers. So the two smallest numbers are going to be the square root of 3 halves, comma, put it in the original, 5 halves. And then it's also going to be negative square roots of 3 halves, comma, 5 halves. Now that's putting it back into here. Okay? So there they are. I'm not going to check the second derivative, but you can if you'd like. All right? In the issue of time. But we have one more here. One more on your sheet. It says an open box. So when I do an open box, I cut out these right here. And these are x's. I'm going to make them all the same. All right? So I'm going to cut out this open box so that when I fold it, I make an open box. We want the maximum volume. And we were told this guy is 20. We're told this guy is 25. So if we want a formula for the volume, the formula is going to be volume equals, well, this is going to be x. The height is going to be x when I fold, times, it's supposed to be a parenthesis, all right, times, this is going to be 20 minus 2x. This is going to be 25 minus 2x. I'm going to leave the rest to you. How nice am I? I'm going to leave the rest to you. I would use a calculator because at some point you have to use the quadratic formula. All right? So you play with that. I have some other stuff for you to play with. All right? So it's just the same thing. You get in two equations, solve for one, plug in, substitute into the other, get the derivative, and then you're looking for min or max. Easy enough, we hope. All right. So here's what I have for you to do. I want you to finish number 4 from this worksheet, and you'll have the worksheet, okay? And that's that last problem. Then I want you to do 3 to 11 odd. Here's the answers. The answers are in the back of the book, so I save you from the back of the book. You can just pause this, do the questions, and they're right here, okay? Tomorrow, we'll look at something a little bit more of, we'll look at more of this. Maybe I'll give you a quiz, a one-question quiz, who knows? All right, that's just keep you on your toes, of course. That's it. Hopefully, you've learned a lot about optimization, using the derivative, and another way, yet another way to use a derivative to find something out. All right? Thank you. See you tomorrow.